What if the most advanced highways on Earth weren't built on land, but hidden beneath the ocean? Right now, beneath crashing waves, violent currents, shipping lanes, and millions of tons of seawater, cars are moving at highway speeds. No bridges above, no ferries battling storms. Just pure engineering operating silently below the surface. This isn't a futuristic concept or a science fiction fantasy. This is happening today. Over the last decade, China has quietly pushed infrastructure beyond limits most countries wouldn't even attempt. Entire expressways beneath megacities, highways drilled through solid mountains, tunnels carved under rivers, lakes, and open seas. These projects operate in environments where a single mistake could flood kilometers of tunnel in seconds, where pressure, earthquakes, corrosion, and human error are constant threats. And yet, they work. In this video, Innovate Tech is uncovering China's underwater highway revolution from start to finish. Why China chose to build beneath the sea instead of above it. How engineers keep these tunnels safe under crushing pressure. What it actually feels like to drive through them. Why the rest of the world is watching closely. And what risks still remain. This story isn't just about roads. It's about how transportation, cities, and engineering are being redefined beneath our feet. So buckle up, because the future of travel might not be in the sky, it might be under the waves. Why build a highway underwater? China's greatest infrastructure challenge isn't a lack of technology, it's geography. The country is defined by massive rivers, crowded coastlines, island cities, and some of the busiest shipping routes on Earth. Millions of people commute daily between economic zones separated by water, while trillions of dollars in goods move through ports every year. Traditional bridges create serious limitations. They disrupt shipping lanes, require enormous land space for ramps, and are highly vulnerable to typhoons and extreme weather. As cities expand, bridges often become traffic bottlenecks instead of solutions. Ferries aren't much better. They're slow, capacity limited, and heavily dependent on weather conditions. A single storm can shut down an entire connection. Every extra minute of travel has a cost. It burns fuel, increases emissions, wastes time, and slows economic growth. China needed a solution that was fast, reliable, weatherproof, and capable of handling massive traffic volumes without interrupting maritime activity. So instead of building over water, or endlessly around it, China chose a radical approach. Go through it. Underwater highways allow cities to stay connected 24/7, unaffected by storms, tides, or ship traffic. They shorten travel distances, reduce congestion on the surface, and create direct links between economic hubs. These tunnels aren't shortcuts. They're strategic lifelines built to keep megacities moving in a world where efficiency matters more than ever. What is China's underwater highway? China's underwater highways are not just tunnels. They are a new category of transportation infrastructure. Unlike older subsea tunnels designed mainly for trains, these projects are built for full-scale road traffic. Cars, buses, freight trucks, and emergency vehicles move through multiple lanes at normal highway speeds. Each tunnel functions as a highly controlled environment. Advanced ventilation systems constantly refresh the air. Fire-resistant linings protect the structure for hours in extreme heat. Real-time sensors monitor pressure, temperature, vibration, and microcracks every second. At their deepest points, many of these tunnels lie hundreds of feet beneath the seabed, buried under layers of rock and sediment. Above them sits millions of tons of seawater, applying continuous pressure. One failure, one structural weakness, and the ocean takes over. To prevent that, engineers use multiple waterproof membranes, flexible joints that absorb movement, seismic isolation systems, and redundant drainage networks. If one system fails, others immediately take over. Emergency escape routes run parallel to the main roadway, allowing rapid evacuation if needed. Control centers monitor every meter of tunnel around the clock. These highways aren't experimental. They're already operational. Every day, hundreds of thousands of vehicles move safely through environments once considered impossible for road traffic. Engineering the impossible. Building a highway beneath water is one of the most dangerous engineering challenges on Earth. First, there's water pressure. At depth, Pressure increases relentlessly, pushing against every square meter of tunnel wall. Engineers counter this using ultra-thick reinforced concrete, steel linings, and precision-designed joints that flex without cracking. Then there's seismic risk. Many coastal regions of China lie near fault zones. These tunnels aren't designed to resist earthquakes rigidly. They're designed to move. Seismic isolation systems allow different tunnel sections to shift independently during tremors, preventing catastrophic failure. Leaks are the ultimate nightmare. Underwater, even a small leak can escalate into disaster within seconds. That's why tunnels rely on multi-layer waterproofing, pressure-controlled drainage galleries, and sensors that detect moisture instantly. Construction itself is a battle against nature. Massive tunnel boring machines operate beneath seabeds, cutting through rock while simultaneously installing tunnel segments. These machines must maintain perfect pressure balance to prevent collapses or water intrusion. Engineers are essentially drilling a precise hole through the earth, while the ocean actively tries to crush it shut. Every meter completed is a victory of precision, planning, and constant monitoring. This isn't brute force engineering, it's survival through control. Inside the tunnel, a high-tech world below. Driving through an underwater highway feels nothing like a traditional tunnel. From the moment vehicles enter, everything is carefully engineered to protect both safety and psychology. Lighting systems automatically adjust brightness and color temperature to reduce eye strain and fatigue. In some tunnels, gradual light transitions simulate daylight, helping drivers maintain focus and orientation even deep below water. Air quality is continuously monitored. Powerful ventilation systems refresh the entire tunnel volume every few minutes, removing exhaust fumes faster than many surface roads. During emergencies, airflow direction can instantly reverse to control smoke movement. Fire safety is built into every layer. Fire-resistant linings can withstand extreme heat for hours. High-pressure water mist and cannon systems activate within seconds, isolating danger zones. Parallel emergency corridors allow rapid evacuation, while shelters provide oxygen, communication systems, and medical supplies. Drivers can directly contact control centers through emergency phones and digital panels. Psychological comfort matters just as much as engineering strength. Wide lanes, high ceilings, soft lighting tones, and visual depth cues reduce claustrophobia and panic. The result is surprising. Many drivers forget they're traveling beneath oceans or rivers until they emerge on the other side in a fraction of the usual travel time. This isn't just a tunnel. It's a carefully controlled underground world designed for humans, not just vehicles. Why this project matters. China's underwater highways represent a turning point in global infrastructure thinking. As cities grow denser, surface land becomes scarce and expensive. Building upward increases congestion, noise, and environmental stress. Moving major traffic corridors underground and underwater frees valuable surface space for housing, parks, and pedestrian areas. Economically, the impact is enormous. Cutting commutes from hours to minutes boosts productivity, reduces fuel consumption, and lowers transportation costs for businesses. Over decades, these time savings translate into billions in economic gains. Environmentally, shorter routes mean fewer emissions. Reduced reliance on ferries lowers surface noise and marine traffic congestion. While construction does disturb ecosystems, long-term operational efficiency can offset some environmental damage. Globally, other nations are paying attention. Island countries, coastal megacities, and regions divided by rivers face the same challenges China does. If underwater highways prove safe, durable, and scalable, they could become a global model. This isn't just about China building big. It's about redefining how future cities connect when traditional solutions no longer work. Underwater highways are not the end goal. They're the next step. Risks and controversies. Despite their success, China's underwater highways raise serious questions. Maintenance is a major concern. These tunnels require constant inspection, advanced monitoring systems, and long-term financial commitment. Repairs underwater are far more complex and costly than surface infrastructure. Emergency scenarios worry critics as well. While tunnels include redundant safety systems, evacuations during extreme events, such as major earthquakes or large-scale collisions, remain a challenge. Environmental impact cannot be ignored. construction disturbs seabeds and marine habitats, potentially affecting ecosystems for decades. Scientists argue that large-scale projects must be carefully regulated to prevent long-term damage. There are also concerns about transparency. Mega projects of this scale require public trust, clear safety data, and long-term accountability. However, history provides perspective. Railways, subways, suspension bridges, and skyscrapers were all once labeled too dangerous, too expensive, or unnecessary. Progress has never been risk-free. China's underwater highways sit at that same crossroads, where ambition meets uncertainty, and the future is decided by whether innovation outweighs fear. The future beneath our feet. For thousands of years, humans built over obstacles. We bridged rivers, we climbed mountains, we crossed seas from above. Now we're doing something different. We're building through the planet itself. China's underwater highways are more than concrete, steel, and sensors. They represent a shift in mindset, a belief that geography no longer defines limits, only challenges. Oceans are no longer barriers. Rivers are no longer dividing lines. Mountains are no longer roadblocks. The future of transportation may not be in flying cars or space travel. It may be hidden beneath our feet, operating silently, efficiently, and invisibly. These projects show what happens when engineering ambition meets long-term vision. They also raise important questions about risk, responsibility, and sustainability. Questions the rest of the world will have to answer soon. One thing is clear, building only on the surface is no longer enough, and the next chapter of human movement is being written underground. If this deep dive expanded how you see engineering in the future, hit the like button. It helps Innovate Tech reach more curious minds. Subscribe to Innovate Tech for more stories about mega projects, future technology, and hidden technologies shaping our world. And comment below, would you feel comfortable driving through an underwater highway, or does it terrify you? The world is changing fast. Innovate Tech keeps you ahead.